In this question, we determine the rate at which average cost is changing when 400 jackets have been produced. We are given this cost function C of x, which represents the cost function to produce x jackets. It's given as 950 plus 15 times root x. So first, I'm going to write the average cost function. So it is given as average cost, and this equals C of x over x. So let's find this average cost function. So plug in C of x, which is 950 plus 15 times of root x, and this is all over x. We can simplify this. So I'm going to put this as 950 over x plus 15 root x, and this is over x. Let's simplify this, or we can rewrite this in exponential form. We can write 1 over x, this in exponential form as x raised to the power of negative 1. Also, we write root x, this we write as x raised to the power of 1 half. Let me do that. So this becomes 950 times x power minus 1 plus this becomes 15 times of x raised to the power of 1 half, and this is over x. I can write this x as x raised to the power of 1. Now we do some algebra, that is when we divide the exponents in the form like a power b divided by a power m, and this equals a raised to the power of b minus m. So we can combine these two quantities using this law of exponents. So basically we have to subtract the powers. So let's do that. So therefore we have 950 times of x raised to the power of negative 1 plus 15 times of x raised to the power of 1 by 2 minus 1, and 1 by 2 minus 1, and this equals 1 by 2 minus 2 by 2. I write 1 as 2 by 2. So this equals 1 minus 2 by 2, which equals negative half. So let's replace that. So therefore this equals 950 times x raised to the power of negative 1 plus 15 times of x raised to the power of negative half. I specifically write in exponent form so that we can find the rate of the average cost function. So this is average cost function, and in symbolic notation we can write this as C bar of x. So this is the symbolic notation for the average cost function. Okay, now that we have determined the average cost function, that equals 950 x raised to the power of negative 1 plus 15x raised to the power of negative half. To find the rate at which the average cost is changing, we have to basically find the rate of this c bar of x, that is the derivative of this average cost function. So let's find the derivative with respect to x on both sides. The derivative of c bar of x, we can write this as c bar prime of x. So this basically represents the rate of change of, this is rate of change of average cost function, average cost function. And so on this right side we have to differentiate these two terms. So I put this 950, which is a constant, and then find the derivative of x raised to the power of negative 1 using the power rule of derivatives. That is, if we have x raised to the power of n, its derivative is nx power n minus 1. That is, we put this n in front and raise x to the power of n minus 1. So similarly, I can put this negative 1 in front and raise x to the power of negative 1, negative 1. So we are done with the derivative of x power minus 1. Now let's do the same thing for finding the derivative of x raised to the power of negative 2, negative half. So I put this negative half in front and then raise x to the power of negative 1 by 2 and then negative 1. We can simplify this further. So this gives, I can put this as 950 times negative 1 is 950. And this is x raised to the power of negative 1. Negative 1 is negative 2. And here I have a negative quantity because 15 times of negative half is negative 15 half. And then x raised to the power of Negative 1 by 2, negative 1. This simplifies to negative 3 half. Let's simplify this further, or we can put this in positive powers of x. So now I'm going to rewrite this as negative 950 over x squared. And the second term, I'm going to write this as negative 15 by 2. And this x raised to the power of minus 3 by 2, I write this in the denominator as x raised to the power of 3 by 2. Okay, so this basically represents the rate of change of average cost function, that is c bar prime of x. So this is the rate function for average cost function. In fact, we can now rewrite this in a different form, that is specifically for x raised to the power of 3 by 2. I'm going to put this in a different form, that is x raised to the power of 3 by 2. I can write this as x raised to the power of 1 half, and once again raised to the power of 3. So this equals x raised to the power of 1 by 2. In terms of radical form, we write this as square root of x, and this is raised to the power of 3. That is, we have to cube this square root function 3 times. That is, we have to multiply the square root of x with itself 3 times. So let's do that. Now this root x times root x is x, and then we have root x. So x raised to the power of 3 by 2 basically is x times of root x. I'm going to write that over here. So we have c bar prime of x. So this equals negative 950 over x squared minus 15 by 2 times of x to the root x. I'm writing this in specific form so that it is easy when we calculate for 400 jackets. That is the rate at which the average cost is changing when we plug in x equal to 400. So let's plug in x equals 400 into this rate function. So therefore we get c bar prime of 400, and this equals negative 950 divided by 400 squared minus 15 by 2 times of this is x is replaced as 400, so it becomes 400 times the square root of 400. We can simplify this further. So this equals negative 950 divided by 400 square is I put this 16 and then put 4 zeros minus this equals 15 by 2 times of 400, which is 800 times square root of 400 is 20. So 800 times 20 is 16,000. In fact, I can replace this as just 16,000. So I write 16,000 here. Let's simplify and evaluate this. Look at here, we have 160,000, and this is 16,000. So 160,000 is the common denominator. That means we can multiply and divide this by 10 so that we get 160,000 for the second fraction. So therefore this becomes negative 950 over 160,000. This is the first fraction. And the second fraction is 15 times 10 is 150. So this is negative 150 over 160,000. That is 16,000 times 10 is 160,000. Now that we have common denominator, we can combine the numerator terms. So it is negative 950 minus 150, and this is over 160,000. And this equals, we add these two numbers and put negative sign. So it is negative 1100, and this is over 160,000. We can now plug this into the calculator, and when we do that, we approximately get negative 0.00 0.06875, and its unit is in dollars. This is per unit or per jacket. So we have to put this unit as in dollars. So I'm going to put this in dollars. Therefore, we see that the average cost is changing at the rate of negative 0.006875 per jacket. This is not unit, this is per jacket. And since we have a negative term, we have a negative quantity, we see that the average cost is decreasing at a rate of $0.006875 per jacket.